Following on from the earlier video, we were trying to integrate this. Then we then use completing the square to take us to here. And then now note that this thing here is of the form something squared take away a constant. So looking back at this, here, we can see that it's something squared take away a constant. So our integrand contains this. So remember, we've seen this table before in the past. Whenever your integrand contains something of this form here, we should make this to be our substitution. Make this to be our substitution. And when you make this to be your substitution, then this whole thing here becomes this. And also something you should note is that at the moment you've got something squared. You've got a squared here. At the moment you've got a squared here. The substitution is just the a. And then what you get is just the a. Not the squared, just the a. Something to note. So remember, when your integrand contains something of this form here, we should make this to be our substitution. And when you make this as your substitution, then this whole thing here becomes this thing here. And we've seen why in one of the earlier videos. So if you don't understand why, then track down one of the earlier videos. So let's start again. We were trying to integrate this, but then this is not in any of these in the form of any of these three here, because this is because this here is a constant. Sorry, this here is not a constant. It contains x, but we need a constant. We need a constant. Because this is not in because this here is not a constant. We need to use completing the square. Completing the square took us to here. So now this thing here is a constant. So let's make the substitution first. So let u equals this thing here. So now put u into here. Du equals dx. So put this into here. Then this whole thing here then becomes this. Now this is something. So now you can see that something squared here, and then now this here is a constant. This is a constant. This is a minus. This is a minus. So we should be making use of this. Okay. Well, our integrand here contains this. So now our next step would be to make this substitution. So let u equals this thing here. Okay. So if your integrand contains this, then you should make this substitution. So make this to be our substitution. Now the minute you make this substitution, then this whole thing here becomes this. So the minute you make this substitution, then you will automatically get this. You will automatically get this equaling this. You will automatically get this equaling this. What that means is you will automatically get this to be this. Okay, well, and anyway, hang on, let's go back one step. We were here. We've identified that we needed this, so we need to make this substitution. So make this substitution. The minute you make this substitution, you will automatically get this. And then, well, looking at this here, differentiate this, that will then give you this. Now substitute back into here, then this thing here then becomes this. Okay, and then you can see the 10 cancels out, the 2 cancels out, leaving you sec d theta. Now we spent a lot of time trying to integrate this in the past, so we've actually seen this. When you integrate this, you will get this, and it is quite a lot of work doing this. Track down one of the earlier videos. So when you integrate this, it will give you this. So what that means is that when you integrate this, it will give us this. Okay, it will then give us this. And then we remember when you get to this stage here, when you get to this stage here, scroll back to see what this is and what this is. Now let's just look at this. When you get to this stage here, scroll back. So hang on, scroll back. We said let u equals this thing here. So sec theta is actually u over 2. So going back down here, when you get to this stage here, scroll back to see what this is, scroll back to see what this is. So when you scroll back, this thing here is u over 2. Now this thing here, what is this thing here? Let's scroll back. We said, well, we've got this thing here equaling this thing here. So divide both sides by 2. Then tan theta is actually this thing here. Tan theta is actually this thing here. So we can put that into the tan theta. So that will then take us to this. Okay. So when you get to this stage here, scroll back to see what this is, and then scroll back to see what this is, and then that it turns out to be this plus this. And earlier we said let u, or maybe in the previous video as well, let u equals x plus 2. So now we can put this back into the u. That will then give us this. Now this thing here is actually this thing here, because when we first started, we started out with this. Integrate this, but then we then use completing the square to take us to here. Okay, so in a way, this thing here is exactly the same as this thing here, because remember when we first started, out, we started out with this, and then we used completing the square to take us to here. Well, this thing here is the same as this thing here. Well, think about it. When you are, this thing here is exactly the same as this. Think about it by staring at this. By staring at this, hopefully you can see. So our final answer is this whole thing here. And something to note. When you have a natural log of something, just make sure that in your mind, just keep in your mind that this thing here should be a positive. It shouldn't be a negative. So another way of writing this would be something like this: absolute value here. But you can write it like this. But just bear in mind that this thing here, just make sure that this thing here is not a negative. This whole thing here, okay? But if you don't understand why. Why is it that you can get from here to here? Then stare at this. Hopefully it will come to you. Okay.